Hello guys, welcome you all for this end-to-end session on AIML where you guys gonna learn everything in order to become a successful data scientist. Hope you guys are enjoying. We have just stepped into the another thing of I will say level 2 of this data science field where we are just exploring the different algorithms present in machine learning and their coding part. So lastly we are just discussing about the decision tree and how it is performing, what are the key concepts in it, how to build the decision tree, like those things we have just discussed in the previous session. So we're gonna continue that. So before just going to this session, as always, I just request every one of you to just go through all the previous session videos so that you can have a better understanding of what we are saying. So hope you guys have a proper understanding. If you guys have watched everything, like we have worked on the data set, like what is data, how to look into the data exploration, how to handle the data, where to collect the data, like those things, and we have stepped into the machine learning process that we have stepped into different algorithms something called as a linear regression, multiple linear regression, logistic regression. Now we are just moving on to some algorithm called as decision tree. Okay, hope you guys have understand everything. So yeah, so guys, this is a continuation of previous session, so make sure that you guys have watched the session. So moving on, we're gonna go for today's session, so without wasting any time. So evaluating decision tree performance, how to evaluate it. Since it is more often used for a classification problem, we can use all the metrics used for classification. Accuracy, it's a measure of proportion of correctly classified instance in the dataset. It is commonly used metrics, but can misleading if the data is imbalanced. Yeah, it's true. Okay, when we are having a positive and negative samples, when there is an imbalanced form, like positive sample is 90% and negative sample is 10%, then there is an imbalance created, right? So that's the reason, like, this accuracy is not that much a good metrics. Then we are having precision. Precision measures the proportion of correctly predicted positive instances among all the predicted positive instances. It is relevant when minimizing the false positive is crucial. Okay, whenever we are having a positive samples, okay, then we can go for this precision. Recall measures the proportion of correctly predicted positive instances among all the actual positive instances. It is important when minimizing the false negative in this session. Okay, when we need a positive sample, we need to go for a precision kind of thing. When we are looking into negative samples, we need to go for a recall kind of thing. Okay, now you guys can understand, right? Then F1 score, it's a harmonic mean of both precision and recall, providing a balanced measure of performance essentially when the data set is imbalanced. Okay, now you guys can get an idea, right? More often used metric is accuracy, but it has a problem of something called as whenever there is an imbalanced data set, we doesn't able to believe or look into accuracy. So when your data is fully occupied with a positive sample, then go for a precision. When negative sample, go for a recall. When the data is imbalanced, then go for F1 score. Okay, so these are the evaluation metrics that we are having. You can just play out it and let you know whichever metrics that you need. Okay, so yeah, that's from my side. The board is all about the evaluating this decision tree performance. Yes, sir, over to you.
Yeah, so evaluating decision tree performance, so we have four parameters. We can use four techniques, which is one is accuracy. Accuracy measures the portion of the correctly classified instances in the dataset. Whatever is correctly classified, okay, that is the first part of accuracy. Then it is a commonly used metric but can be misleading if data is imbalanced. So you need to have a balanced data. Okay, then and only accuracy is going to help. Okay, so then we have precision. Precision is measures the portion of correctly predicted positive, okay, instances among all predicted positive instances. It is relevant when minimizing false positive is crucial. False positive, like suppose there is a data where you have said, okay, there are two people, you have suppose 10, let's say you have 10 data points. So out of that you have six which are positively positively classified, predicted at positive instances. So then out of that two are there which are falsely positive. So suppose you will say, oh, your precision is 60%, out of 10, right? But actually it is not 60 because they are falsely positive, and minimizing falsely positive which are not positive, which might be negative. So, uh, but data has learned as a falsely positive, right? So, for precision, that's a challenge. So that should be minimized. That is the insight which we need to consider. So recall is a measure that the portion of correctly predicted positive instances among all actual positive instances. Okay. So I'll say whatever precision has predicted positive predict instances among all positive. So recall is a measure of measure of the portion of correctly predicted positive, correctly predicted, okay, instances among all actual positives, which are actually positive. They could be falsely positive also, guys, but it should be actually positive. Okay, so it is important when the missing false negative is essential. It is important when minimizing false negative is essential. False negative, right? So that means that suppose there are, I gave example of 10 data points, right? So 10 people, okay? Suppose they are falsely negative, let's say two more, and okay, now the example is like six are correctly positive and two are falsely negative. So you are thinking your data is 60% correct, but your data is actually 80%. So that is why we need to minimize falsely negative, and we need to minimize in precision falsely positive. Okay, so means that your data point, your data set is not, it should be correctly positive, not falsely positive. It should be correctly negative, not falsely negative. So this is how you can understand. That is the main idea that you need to consider while you go for precision or recall. Then we have F score, F1 score, which is harmonic mean of the precision and recall, provides a balanced measure of performance, especially when the data set is imbalanced. So again, it is the game for F1 score is like it's a balance. It will balance precision and recall, but again, you should be minimizing falsely positive and falsely negative in precision and recall. Then you will have a balanced F1 score, guys. So data should not be like, data set should not be like imbalanced. Okay, so so F1 score again, it is a harmonic mean of precision and recall. Like it is mean of the both precision and recall, providing a balanced measure of performance. Okay, so always model should be balanced, then and only it will generalize. Okay, and F1 score does that. It will balance recall and precision, and especially when data set is imbalanced. Imbalance can be, there would be skewness, there would be a positive skew or negative skew or biased or outliers. It will not be balanced, right? So F precision and recall will help us to balance it. Okay, let's move to the other section.
Yeah, sure, sir. So moving on, we're gonna see the advantages of a decision tree. So first is easy of interpretation. The thing is, decision trees are visually intuitive and easy to understand, making them suitable for explaining the predictions and gain insights from the data. Yeah, we know the entire flow. It's a route, and this is a decision it is made to bring these branches, and this is a decision is made or done to bring these sub branches, and these are the values that we are having in the leaves. Like that, we will be having the flow. So easy of interpretation. Simplicity. Decision trees are relatively simple to implement and require minimal data pre-processing, making them a practically choice for quick analysis. Yeah, that's true. The reason is we can use this for both classification and regression, and it also requires very less pre-processing. Okay, the thing is, because like each and every step it's gonna apply the decision rules, right? So it will split the unnecessary data or unnecessary kind of overfitting, underfitting kind of thing, but like it's to some extent. Okay, then flexibility. Decision tree can be handled both categorical and numerical data, making them applicable to wide range of data types. Yeah, it can handle all kind of data. So, and it is not a case like we should not do pre-processing of converting the categorical to numeric, but there is a possibility that machine learning can handle it. Okay, next, non-parametric nature. Decision tree do not make strong assumption about the data distribution, making them robust to outliers and non-linearity. The thing is, here in decision tree, we doesn't have a specific formula. Okay, it's purely depends on impurity. It will calculate the impurity of the data set. It purely depends on the data set. It will just create a tree first. If a impurity is high, it will recreate its tree. If its impurity is low, it will just make the tree. Okay, like that it will do. There is no specific formula as we are having for linear regression, multiple linear regression, and logistic regression. It is purely depends on original data set that we are giving. Okay, that's the reason it is like non-parametric in nature. Okay, so hope you guys have understand this. So yeah, that's what all about the advantages of decision tree. Yes, sir, over to you.
Yes. So advantages of decision tree, guys, easier to interpret, sorry. Decision trees are visually intuitive, like when you will see the decision trees, they are like visually intuitive. You can understand easily, okay? You can easily understand, make them suitable for explaining prediction and gaining insights from the data, okay? Then simplicity is there. Decision trees are relatively simple to implement, require minimal data processing, making them a practical choice for a quick analysis. See, your decision tree can be with two nodes, guys. Like it can be biggest also, like, but then there are limits to it. You will have overfitting if it is a big decision tree. Flexibility. Decision trees can handle both categorical and numerical data. That is the best thing. You can you can turn array into a decision tree, right? That's the best thing. Suppose you have a array, whether you have a uh, normal array or multi-dimensional array, so you can turn that into a decision tree simply. That's the best thing. It can handle categorical and numerical data, making them applicable to wide range of data types. Okay, that's what I said. Like you can use different type of data types. Okay, that is the flexibility with the decision trees. And non-parametric nature, decision tree do not make strong assumptions about the data distribution, making them robust to outliers and non-linearity. So that is the like non-parametric nature decision trees have. So they do not make strong assumption about data distribution. Okay, like what is data distribution? Like we talk about norm, like mean data distribution, right? We talk about like in if you see when we do regression or we do other parameters, when we apply other models, we want to see our data is normally distributed, right? But here decision trees cannot do that. They are not strong into that assumption, like for them, because for them it's all about tree branches, nodes, and the root. Okay, and it's not about whether data is normally distributed or not. Okay, that is they are not strongly assumption about the data distribution, making them robust. So because there would be outliers, but then decision tree has its own what say, like it has its own uh, s- strengths and weaknesses. Okay, so then it depends, like you need to know that what is your objective function, problem statement, or characteristics of data, and why you're what problem you're solving, so you can use according to that decision trees. It's not like like you will use it everywhere. So you should know where to use which model. Okay. So yeah, let's move to the other section.
Yeah, sure, sir. So moving on, yeah, we've seen about the advantages. Now we're gonna see the disadvantages. That is limitation of decision tree. Overfitting, yeah, decision tree can overfit the training data, leading to poor performance and unseen data. Pruning and regularization are the techniques that is used to address this issue. Guys, I hope like this is a major thing that I need to say. Whenever you are using decision tree, right, it will be the most possible thing that overfitting will occur because it gonna split based on a decision rule, so it gonna split very deeper. So that's the reason it will lead to overfitting. And another thing is instability. Slightly changes in the data can lead to significant change in tree structure, affecting its predictive power and making it sensitive to noises. Yeah, that's the thing. So if we will create a tree based on the decision rule that we are having based on the data, if you are making any changes to the data, then you need to just work from a scratch, start from the root. Otherwise it will not work. So that is what instability. Then bias. Decision tree can be biased towards features with a higher number of distinct values, leading to the bias split and inaccurate prediction. Yeah, if you are having a column with more number of unique values, then decision tree gives more priority to that column. That's the reason you guys need to go for a scaling kind of thing, or something called as a feature extraction or feature selection, like those things, in order to avoid these problems. Okay, so overfitting, instability, and then bias, these are the, I will say, major problems of decision tree. Okay, so you need to somehow just handle this. For overfitting, we can handle by using pruning and regularization, whereas bias can be handled by creating some new features or some adding some extra features, or the removing or scaling the columns. Instability, like, uh, we need to fix it, because like, we need to fix the data. Okay, if you are giving new things in the data, then somewhat it leads to instability. That's the reason you need to fix the data. For unseen data, you can just have a data in a form of a data which you are given for reading. Okay, just training. Okay, so try to fix this so that decision tree will work good for you. Okay, yes sir, over to you.
Yes. So, guys, the limitations of decision tree overfitting, which is already discussed, guys. When you build a big decision tree, there will be a poor performance. You will, like, you will not get the, because it will learn too much. Okay, so that would be a problem. So on unseen data, and which is like normal concept of overfitting. Okay, whenever you see overfitting, it's like uh, when you eat too much, either you will be sick or you will not perform well. Like you will not be able to work. You will try to sleep or something, right? Similarly, model will not learn. It will go like it will be poor on performance. So we have techniques like pruning, regularization of technique using to address this issue. And then we have instability. That is another limitation. So site changes into the data can lead to significant changes in the tree structure, affecting the predictive power of making it sensitive to noise. It can be like unstable like if it is sensitive to noise. Okay, if it is sensitive to noise, what will happen? It will try to capture that data. Okay, the noise, and that is a problem, huh? That can lead to a biasness. Okay, it can lead to uh, uh, like outliers. Noise can be outliers, noise can be any anomaly. Okay, then bias. Decision tree can be biased towards features with the higher number of distinct values, leading to bias splits and inaccurate predictions. So again, you'll see bias splits. Like when you split into different classification classes data into, so if it is biased splitly, like split biasly, then what will happen? Again, it will be biased. And if inaccurate predictions are there, so again it will be biased. So you have to, so in this one, I think slide you have understood overfitting, instability, and bias. So these are very, very important terminologies and ideas. So limitation for decision trees. So it can limit ultimately the performance of your model. Okay. So understand these terminologies properly and at a meta level. So then you will be able to apply properly. Thanks. Let's move to the other section.
Yeah, sure, sir. So moving on, guys, we're gonna see the applications of decision tree in data science. I will say n number of application. Okay, as I always saying, this slide can only accommodate 3 to 4 applications. So I have just put those things. Okay, healthcare. So decision diagnosis and patient risk assessment. Yeah, it is used to identify what is the disease that will come. Like as sir is always mentioning, like proactive kind of things that we can do in healthcare centers. Finance. It is used for credit card score, and then something called as fraud detection and investment analysis, like those things it can do based on the historical data that we are having for the uh, once we pass to edition tree, it can do retail customer segmentation and something called as a product recommendation market, like a sales forecasting. These things can do this is the first thing that we have seen. So decision tree is very useful for classification, regression, and forecasting. So it's not a surprise that it is very useful for sales forecasting. Marketing, lead scoring, and campaign optimization, and something called as a customer chunk prediction, like those things. For those things, this decision tree is very useful. So it is not limited to this case. There are different domains are useful, like in agriculture they are using, and something like semiconductor industry, and some social media entertainment industry, they are all using. So it is not limited to this application, but like it has a vast range of application. So yeah, that's the thing. So decision tree is like a how tree is useful in tree is present everywhere. Like decision tree also, it's a wide range of application in every domains. Yeah, sir. Over to you.
Yes, so guys, application of decision tree in data science, if you see, there are n number of data like application areas where we can use. We have already mentioned that wherever data is generated and we can automate and we can build better models and optimize the objective function or solve the problems. So we can use data science and we can use AIML data science everywhere. So here application of decision trees in data science. So here we have specific industries, but you can use it in other industries also. Healthcare, you can use it for disease diagnosis, like whether somebody has breast cancer or not, has this disease or not, patient risk assessment, finance, credit scoring, fraud detection, investment analysis, retail, customer segmentation, product recommendation, sales forecasting, marketing, lead score, campaign optimization, customer churn prediction. So then there are a lot of other segments where you can use it, but it depends on the characteristics of data and the objective function, the problem statement you have, because you need to choose right model for right fit. I'll say right fit, okay? Best fit, not right fit, best fit. So, as per the objective function and the characteristics of data. Thanks. Let's move to the other section.
Yeah. So, guys, that's all about we are having for decision tree. So, last session and this session, we have just discussed about the theoretical concept of decision tree. What is decision tree? What are the important concepts of decision tree? How to interpret the decision tree? How to create the decision tree? What are the advantages, disadvantages, and then applications? Okay, guys. Now you have a clarity of what is a black box behind the decision tree, and we have clarity of theoretical knowledge. The next session, we will be moving on to the coding part, where we're gonna have an hands-on experience. Hope you guys have enjoyed this session. If you guys just enjoy the session and whatever the things that you have enjoyed, just mention in the comments. If you guys have any doubts, just mention in the comment. We will take up and we will solve your doubts. So yeah, that's it all about this session, guys. Thank you so much. We will all meet in the next session, guys. So until next session, bye, guys. Take care.
Yeah, guys, keep learning. 5 to 10 times do all the reinforcement learning. 5 to 10 times go watch all the sessions. Build patience, have patience, consistency, persistency, and keep learning deeply and give us feedback how we can improve each session. and also subscribe to our channels and press the bell icon so that you will get notification, and keep learning deeply end to end, and do all the assignments and have a long term objective function for your career. Keep learning. Thanks.